Welcome, ladies and gentlemen, to lesson 7.1 in your textbook. Starting on page 352, I can calculate the circumference and the area of a circle. So make sure you have your vocabulary out, and you're going to want to take good notes, having shapes, having formulas, and showing all your work with labels. So, circumference and area, but first we should talk about parts of a circle. Okay? You don't need to write all of these words, but it would be good to have the picture down and then have these words in your vocabulary. So this is a circle, and a circle is a set of points on a plane that are the same distance away from the center. So anywhere from the circle, here to here to here, 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 anywhere I were to go would be the same distance from the outside to the inside of the circle. Okay, and that would be the center. Okay, the segment from the center to any point is called the radius. So all those lines I just drew are kind of called a radius. Not kind of, they are called a radius. From here to here, and then there to there, each of those would be a radius from the center to the outside. A chord is any line segment with both endpoints on the circle. So for example, this would be a chord. So it's going from any endpoint to another, but it's not necessarily going through the circle. A diameter is a chord that goes through the center. So the diameter goes through the center of the circle, unlike the other chords I just showed you. What you'll notice, when I draw it that way, what you'll notice is that the radius is half of the diameter. So the diameter is the longest chord. Distance around the circle is called the circumference, and the ratio of the circumference of a circle to diameter is always pi. Okay? So the ratio of the circumference of a circle to its diameter, and that just means right here. Ratio is a comparison of two numbers, and then it said is, and we call that number pi. So that number is pi. And it's the same, we use 3.14 or 22/7 are often approximations, not exacts, for pi. Okay? This can also be written. So to find circumference, notice what you'd have to do is bring your diameter to the other side, which gives us our usual formula of circumference is pi times diameter. So circumference. Circumference is the distance around. So circumference is pi times diameter when you're given diameter, but sometimes you're just given radius, so it's also circumference is 2 pi r. Because our radius, we know, is half of our diameter. So our radius is our diameter divided by 2, and our diameter is our radius times 2, in case you need to find one of those. Probably some good information to have down, circumference of a circle. Again, just talking about diameter and radius and the relationship. And then let's give some a try. A study tip. Okay. So sometimes you're going to be asked to round to the nearest tenth. If you use pi, you're going to have to do that at the end. If you use 3.14, that'll result in close approximation, but pi will give you a more accurate answer, and then you'll round. So, if we are asking to find the circumference of a circle and round to the nearest tenth. So in your book, I believe you are given a circle with a diameter of 9 feet. So first thing I do is I write down the formula that I think I'm going to need to use. Since I'm given a diameter of 9, I decide to use my formula. Circumference is pi times diameter.
Mr. Call 42150. Mr. Adam, please call 42150.
So then I can just plug in what I'm given. My circumference is my pi times my diameter, which is 9. This is also written as 9 pi. So sometimes you're going to be asked to leave your answer in terms of pi. At this point, you would stop right here and say, this is 9 pi feet. That would be in terms of pi. Another way is actually that you plug in pi in your calculator. So I do 9 times pi on my calculator, and I get circumference is 28 and 2, 7, 4, 3, and it's going to go on and on. To the tenths place means I look to my hundredths place, and if it's 5 or more, I round up. So then I'd say my circumference is approximately 28.3 feet. Again, circumference is the distance around. I'm not multiplying units times units, so I don't square units. Okay, one more from the book. If you're given a circle with a radius, so half the length, of 7.2, you would choose to use the formula circumference is 2 pi r. This is how you're going to show your work. You're going to plug it in, what r is. Generally, I like to multiply my numbers first in case I have to go to terms of pi. So I multiply my 2 and my 7.5. So I get circumference is 14.4 times pi. Again, in terms of pi, I would leave it as 14 and 4/10 pi centimeters. But to actually work it out, using pi, I get my circumference is 45.2389, etc. So then I round to the tenths, so I look to my hundredths. It's not 5 or more, so my circumference is approximately 45 and 2/10 centimeters. Had I used 3.14 instead of pi, I would have gotten the same thing. So just be off a little bit decimals sometimes. Some extra examples if you want to try them and bring them to class. Area investigation. So we're going to talk about area now. And we're going to talk about area can be decomposed into congruent wedge-like pieces. Then the pieces can be arranged so that they resemble a parallelogram. Kind of like a pizza. Okay? So what you notice is that if it's split up evenly, your radius is actually kind of half of your base. And that the top part is half the circle, so that'd be half the circumference. And that's what the 1/2 C is standing for. And the base would also equal that much. So since the circle has an area that is relatively close to the area of a parallelogram, you can use the formula for area of a parallelogram to find the formula of a circle. So this is kind of how it was developed. So area of a parallelogram was base times height. We noticed that the base was half of the circumference. So we replaced that. We noticed that the radius, okay, is on the outside. So we're still multiplying it by, that's kind of like the height right here, okay, because it's from a wedge to the center, so that's half the circle. So any one length of these pieces, the height, is kind of like the radius. So then we plugged in the circumference formula, and what we noticed was half of 2 is 1, so that kind of went away. Pi, and then r times r is r squared. So our formula for area turns out to be pi r squared. All shapes have something in common. So, area of a circle. This is the space inside the circle. How much is filled up? So, area formula, we want that down. And its area is pi times the square of the radius, or pi r squared, radius squared. Keeping PEMDAS in mind, we know that we would do squares and exponents before we would do multiplication. So again, to estimate the area of a circle, square the radius, then multiply by around 3 to estimate, since 3.14 is close to 3. So we're going to find the area of this circle given its radius of 8. So I use my formula. I write that down. Area is pi r squared. I'm going to replace the value I'm given. So area is pi times 8 squared. Again, knowing I do exponents before multiplication. So I have area is pi times 64, which again, in terms of pi, you will write that as 64 pi. And since here you did units times units, it's actually going to be units squared for your answer. Not doing that way though, we would still do 64 times pi and get 201.0619. And again, if we're asked to round to the tenths, which is one place behind the decimal, we would look to the hundredths, and if it's 5 or more, round up. So we get that the area is approximately 201.1 square kilometers. Okay, and again, we're getting square units when we multiplied radius times radius. What about when I'm given the diameter? Notice there's no part of this formula that includes diameter. And diameter, radius times 2 and radius squared are entirely different. So do not think that that is, you can just divide this by, that you can just multiply it by 2. You still have to figure out that the diameter is twice the radius. So if you know the diameter, and you know it's twice the radius, divide it by 2 to find out your radius. So it's half of that. So I can plug that in. Area is pi times my radius that I found squared. So then I do 7.5 squared. 7.5 times 7.5, not 7.5 times 2. So then I get pi times 56 and 25 hundredths. Again, in terms of pi, I'd leave it, but I'm going to work it out. Multiply that times pi. Calculators are going to come in very handy, ladies and gentlemen. 100 and... made a mistake. 176.7145, yada, yada, yada. And I would round that to the tenths, looking at my hundredths, less than 5. So my area is approximately 176.7 square feet. Another couple with words, you might just want to draw yourself a picture. So knowing what a radius is, you would draw yourself a better circle than that. Knowing that's 11 inches, then that could help you. Or drawing yourself a full circle with a diameter of 5 meters. So you can try those if you'd like. Word problem. Suppose you walk around the edge of the circular Point State Park fountain and estimate its circumference to be 470 feet. Based on your estimate, what's the approximate diameter? So this is where we're given something and we have to work backwards. So we need our formula. Circumference is pi times diameter. It said I estimated the circumference, pulling out the important information, as 470. So I replace circumference with the value, and that's pi times diameter. Well, to solve for d, I see that d is being multiplied by pi. So to solve that, I do the inverse and divide by pi. So in my calculator, I do 470 divided by pi, and I get 149.605 is equal to the diameter. Well, I check the hundredths place, less than 5. So my diameter is approximately 149.6 feet. And since this is a word problem, I'd write down the meaning, and I would write that the diameter of the fountain is about, and this is an estimate, So I could round up about 150 feet. So again, another word problem for you to give a try on your own. Maybe drawing a picture is always a good strategy. So it says the catalog states that a circular rug, so I would draw a circular rug, and it covers an area, because it covers so much feet, so it looks like you're given your area, and you're looking to find the approximate diameter. So I would use your formula. Notice you're looking for diameter, so you need to know that your diameter is twice your radius. Good luck. All right, rewatch the parts you need to. Try those extra examples. Look in your book. Jump on the online textbook. Lots of good personal tutors. I know a lot of you don't use that enough. And iExcel. iExcel, I believe, for this one is 7x, 21, 22, and 23. Good luck.